everyone, this is Maeve, and we're going to have a look at sprint number 21. Let S of n denote the sum of the digits of n. What is the sum of all positive whole numbers less than or equal to 10,000, for which S of n minus S of n plus 1 equals 17? Okay, let's just try an example. What about 42? What's S of 42? It is 6. 4 plus 2 is 6. S of n plus 1 is S of 43. That's 7. S of n minus S of n plus 1 is minus 1. Okay, that's not good. So how do we get a bigger sum of digits on a smaller number? S of n needs to be bigger than S of n plus 1. Okay, well, what if n ends in 9? S of 49 is 13. S of 50 is only 5. So here S of n is 8 bigger than S of n plus 1. That's good, but it's not good enough. We need it to be 17 bigger. How are we going to do that? Let's have S of n end in 2 9s. S of 499 is 22. S of 500 is 5. S of 499 minus S of 500 is 22 minus 5, which is 17. That's perfect. Okay. What if it ends in 3 9s? 999 and 1000? Those are 26 apart. So obviously that doesn't work. So what we're learning here is our number needs to end in exactly 2 9s. So we're just summing all positive whole numbers less than 10,000 that end in 2 9s but not 3 9s. All right, let's get rid of all this stuff. More space. So we've got our number, which ends in something, and then something that's not a 9, and then 2 9s. We could have it, this is a 4-digit number, and if the first digit could be a 0, so it could actually be a 3-digit number, right? Which means it's between 99 and 899. Or the first digit could be a 1, which means it is 1099, 1199, all the way up to 1899, but not 1999 because that ends in 3 9s, not 2 9s. Okay, we keep going all the way up to the ones that start with 9s. Our biggest one is 9,899. Now, how do we add all these up? These are really ugly numbers. I don't like any of them. It's because they end in so many 9s, right? Which is what we signed up for, but it still looks ugly. So let's fix it. Let's add 1 to each of these numbers. There's 9 of them, so we add 1 to each of them, and then you subtract 9 at the end, and it doesn't change anything. Those are much nicer numbers. Let's get rid of the old ones. All right. 100 plus 200 plus 300 all the way up to 900. The way we sum these is there's 9 of these, right? They start with 1 through 9. So and we add them into 9 pairs. There's 9 pairs, and their sum of each of them is 100 plus 900, but we can't count the pairs twice. We only count them once, so we divide by 2. Still minus 9. Another way of thinking about this is the average of these numbers is 500. 100 and 900 average to 500, 200 and 800 average to 500, and so on. So 9 times 500 minus 9. All right, the next one, same thing, right? We can separate out 1,000 from each of them. That's just 1,000 plus 100, 1,000 plus 200, all the way up to 1,000 plus 900. So it's just the same thing, except that we've got 9,000 sitting around, which means in all we've got 9 times 1,500 minus 9, which is what we would expect, right? We had 500 in the first row, and then we've got 1,000 more because each of these numbers is 1,000 more. So on average, they should be 1,000 more. And we keep going until we get to the last set, which is 9 times 9,500 minus 9. All right, let's get rid of all the stuff we don't need anymore. Now we're just summing all of these numbers. 9 times 500 plus 1,500 plus 2,500, all the way up to 9,500. Let's take 500 away from each of these to make them prettier. We've got 10 numbers starting 0 through 9. So that's 10 500s, and then plus 1,000 plus 2,000, all the way up to plus 9,000. We're still subtracting 90, which is from the 10 9s that we added on earlier, and we have to remember to subtract them. Okay, so just like before, the sum of 1,000 up to 9,000 is 10 times 1,000 plus 9,000 divided by 2, which is 4,500. So we've got our 10 500s, we've got our 10 4,500s, put those together into 10 5,000s. 5,000 times 10 is 50,000. 50,000 times 9 is 450,000, still minus 90. So lots of carrying in this. It's going to be 449,910. If we want, we can add 90 back to that to check that we did it right, but we did. And that is the sum of all positive whole numbers, such that s of n minus s of n plus 1 is 17. That's the answer.
Hi, everybody. This is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.